Hello everyone and welcome to lesson 8.3.1. This is the final lesson in chapter 8. This is a two-part lesson. Today we're going to focus on the first part, how to know if something is a function. Understanding what a function is. Understanding if there is a pattern. Understanding if you can predict the future. There are some things that you can develop a pattern in order to predict the future. And there are other things that there is no pattern. It's just seemingly random. So here's what I want you to do. In problem 8-115, draw a sketch of an example of each graph described below. So in the first one, a graph that neither increases nor decreases. Draw a line in such a way that it is not going uphill, it is not going downhill. Okay, you should have drawn a line that does this. Okay. B, a graph that decreases non-linearly. Remember, non-linearly is a not line. So you need to draw some sort of curve that starts in the upper left-hand corner of your graph and goes down. That's one option. Or maybe it goes this way. Or maybe it goes squiggle. I don't know. Non-linearly. Those are three options. C, a graph that increases linearly, so that means a line going upwards and then decreasing linearly. So a line going up and a line going down, okay? And D, a graph that is consistently increasing. Consistently increasing. Now, I interpret this two different ways. I can think of this linearly because it's consistently increasing. That means it's increasing the same in an upward motion. But I can also think about this in a way like it's always increasing. It's consistently increasing more and more. And that would be a non-linear way. I can see both of those being correct. Okay, so please draw that below. Now, when you drew those, everything that you drew just now represents a function, represents a pattern. But when we have this in a table, okay, we can be a little bit more specific. Now remember, I told you that when we are looking at a table, we focus in on the beginning value. Okay, notice my beginning value here is 2. So I can tell that my beginning value is 2. And then I'm focusing on my growth. What does it take to go from 2 to 8? Well, that's plus 6. Is that true from 8 to 14? Yes, it is increasing in a similar way. I notice that my growth is 6, and that tells me my rule. Now, these are linear functions. These are rules that we have been dealing with for a long time, right? We use rules like this to predict the future, like we did with John's giant redwood. We used his function, his rule, to predict how big would it be way down the road. We do this with functions to help us predict the future. So when we look at a problem like 8-117, function machines, okay? A function works like a machine. Numbers are put into the machine one at a time, and then the rule performs the operation on each input to determine the output. Notice we've got a little machine over here. The 4 goes in, it goes through the machine, and it puts out the grade. Notice, if you think about this like the soda machine, right? Like they've got all these dispensaries, and when you push on the Dr. Pepper, you're going to get Dr. Pepper, right? That's a function. When you push on that machine, you expect to get Dr. Pepper out. But that's assuming that everything is hooked up correctly. So in problem A, B, C, and D, I want you to notice A and B, we are going to push these numbers through the function. And what we are thinking is order of operations. So I'm going to do some mental math. 5 times 4 is 20. And then I think 20 minus 7, that's going to give me 13. My output is 13. When I start with 4, my output is 13. I want you to apply the function in problem letter B. Pause the video to complete those two problems. Okay, now what if I knew the output? Can I work my way back to find the input? So if I put the 45 in the y position, okay, then I can go ahead and say, okay, I've got to find x. Let's see, I'm going to do a side-side flip, flipping this over here. That's going to be add 7 to get 52 equals 5x. Let's see, I'm going to regroup, divide by 5, x equals 10 and 2/5 left over. Now that would be my input. Sorry, that doesn't want to move for me. That would go right there. You could also write 10.4 in its place. Now we use functions all over the place. When I'm calculating your GPAs every trimester, I have a function that helps me calculate everyone's GPA in the entire school very quickly because it helps me use math to my advantage. And that's what we need to see how that is working today. Now, problem 8-118. Some relationships are special in that they are called functions. Functions behave like they should. They help us predict the future. Below are two relationships, one of which is y equals x squared minus 2, which is a function, and the other, x equals y squared minus 2, it is not. Okay? Question letter A. What is the same about the two relationships? I want you to look and write a sentence. What is the same about these two things? Pause the video now. Okay, welcome back. You should have said something about exponents. You could have said something about the -2. You could have said something about how these tables look similar and yet opposite. You could have said something about how these are both U-shaped graphs. Okay? What's different about these? Pause the video to write a sentence about what is different about these two. Okay, now I alluded to many of these, right? Now, in the exponents, one is above a x squared and one is above a y squared. In the tables, same numbers, but opposite rows, right? They're switched. Yes, they're both U-shaped, but notice one U is pointing upwards and the other is pointing to the right. These are vast differences that cause a function to be a function or to not be a function at all. So let's go ahead and look into what makes a function. In a table, a function has no repeating x values. I want you to notice, no repeating x values. That makes a function. Notice over here in this other one, I have 7 repeating itself. Okay, could you imagine going up to the Dr. Pepper machine, and in one Dr. Pepper machine, you press it, you get Dr. Pepper, and you're like, yeah, I got Dr. Pepper. And then it's like, oh, this one isn't quite right. I go over here and I push this Dr. Pepper, and instead I get Mountain Dew. Now, I like Mountain Dew, but if I wanted Dr. Pepper, I would want Dr. Pepper. How is it that you press 1 and get a -3, and in the other situation, you press that same button and you get something else? Okay? This is how a function operates. If you have one x value, it should give you that exact same thing every single time. Okay? If you push that Dr. Pepper button, you should always get Dr. Pepper. Okay, that's how a function works. In a graph, a function has a single y value for every input. Input is the x. So I want you to notice, here's an x value of 5, but I have 2 y values. In a graph, a function has a single y value for each input. For every x, there should only be a single y, not 2. Okay. Let's look and see how to apply this. How to tell if it's a function? Well, what we can do is something that is called the vertical line test. If I looked at this, okay, if I were doing a vertical line test, how many times did it cross? Once. Hooray! It's a function. If I went over to this one, I said, how many times does it cross? 1, 2. Not a function. You have one more problem where you are going to look at tables and you're going to say, is there only one x value? Yep. You're going to look at the x value. Yep. Yep. You need to be able to recognize what is a function and what is not a function. You are looking for repeating x values. If there's only one, it's a function. If there are multiples, it is not a function. So today was the introduction to what is a function and how does it operate. Thanks for coming to today's lesson. Hopefully you found it useful. We'll see you on the next one to catch the second half of lesson 8.3.1. Till then.